Hello, my name is Avery Williamson and I'm with Team 4, and we'll be discussing the source code description, installation, and benchmark application identification for the Beowulf computing cluster. First of all, we'll be providing an overview of the source code for the computing cluster. This code will be used to develop applications that will provide mathematical modeling of organic molecules for the synthesizing of organic compounds for the replacement of stem cell extracts. We will also provide a general overview of the source code installation and benchmark applications that we will use to test the source code. We've identified the following software packages for application development on the computing cluster. The first application is NAM2, which is used for molecular modeling. The second one is CHARM2, which is a compiler for NAM2. The third one is FFTW, which is faster Fourier transform in the West. And lastly is TCL, Tool Command Language. First of all, let's discuss NAM2. NAM2 is a free open source software that can scale to hundreds of processors on parallel platforms and tens of processors on computing clusters. It is created for high-performance simulation of large molecular systems and is based on the CHARM2 software code. NAM2 development is growing because of major trends within computing technologies and discoveries in structural biology. And I just wanted to bring out a couple of larger molecules that have been created through NAM2 simulation. The first one is the satellite tobacco mosaic virus, and then the first one is the satellite tobacco mosaic virus, and the second one is the bacterial flagellum. And as I stated earlier, because of development in computing technology, we have larger machines with larger processors, and it makes computing clusters more affordable for the development of NAM2. Let's discuss CHARM2. CHARM2 is an open source parallel programming language that is based on C++. It supports message-driven execution, allowing calculations that are triggered based on receiving associated messages. CHARM2 is portable and can run on a number of different operating systems, and it's designed to support dynamic and static load balancing. Now, what this feature does is that it allows the flexibility of NAM2 regarding its scalability and reaching its parallel computing performance. FFTW, fastest Fourier transform in the West. This software is also a free open source C library, and it's used to calculate the discrete Fourier transform, DFT, by using conventional application programming interface across a range of computing platforms and systems. FFTW automatically adapts to the hardware platform, the platform's cache, memory size, number of registers, and other factors that will not allow the optimization of programs for more than one machine. It is used to enable particle mesh EROL PME for NAM2. Now, what this allows NAM2 to do is that when it models a molecule, it establishes the long-range factor of electrostatic energy in large-scale molecular simulations. The lab software is TCL, Command Tool Language. TCL is also open source, and it's a simple licensed programming language that provides the following features: programming variables, procedures, and control structures. It can also run on a variety of operating systems. TCL allows the assembling of software building blocks into applications. It is also interpreted when the applications run. Now, what this does is that it makes it easy for applications to be built and refined. Now, and it's used within scripting purposes within NAM2, so it makes it easier to write custom scripts within the NAM2 software code. Now we'll discuss the software installation. In order to build a NAM2 binary from source code, there must be working C and C++ compilers. CHARM2, TCL, and FFT. And here's the general build sequence, and we'll use a 64-bit CentOS Linux server, okay? First of all, you'll unpack the NAM2 and matching C++ source code, and you'll enter the directory. You will then build and test the C++ Converse library. And the reason we have Converse here because Charm2 and Converse are the same code, and Converse supports Charm2. Then you will download and install the TCL and FFTW libraries. You will set up the build directory, and then you will compile the software. And then lastly, you will perform testing using different processors. Now, I wanted to bring this out real briefly is that within NAM2, you can specify the number of processors you want to test on. So if you want to start out with 2 processors, just to make a small test, then 4, then 6. And so you will test out the robustness of the NAM2 software. For benchmark applications to test NAM2, we suggested using the structure of APOA1. APOA1 is a bloodstream lipoprotein particle that contains 92,000 atoms. This particle is one of the most used for benchmarking NAM2. What we also wanted to do is provide an example of NAM2's performance on APOA1 as it runs on different computing platforms. Now, this is NAM 2.6. And one thing, as I stated, one thing I wanted to bring out was this, is that if you notice, regardless of the computing platform, as the number of processors that NAM2 is running on increases, the computing power increases. So NAM2 scales to the number of processors that you run it on. Now I want to summarize everything. There are 4 software packages that have been specified for the Beowulf computing cluster for the mathematical modeling of the organic molecule, the stem cell extracts. All of the software packages are free and open source, so there's no cost as far as purchasing the software to run on the computing cluster. NAM2 is a parallel molecular dynamic code which is created for high-performance simulation of large molecular systems. It's based on the Charm2 software code. Charm2 is a parallel programming language based on C++. It's portable, can run on any system, supports dynamic load balancing, and is scalable, and it's free. FFTW is a C subroutine library that, once again, as we discussed earlier, it automatically adapts to the hardware platform that it's installed on, the cache, the memory size, number of registers, and other factors that will not allow the optimization of programs for more than one machine. And then TCL is a simple open source programming language that provides the following features: programming variables, procedures, and control structures. And it is specifically used to allow the flexibilities of scripting within NAM2. In closing, the software installation is relatively simple, and we have identified APOA1, the bloodstream lipoprotein particle that has 92,000 atoms, for benchmarking, since it's one of the most used data sets for benchmarking NAM2. I'd like to thank you for your time today. That concludes our presentation.